Hello everyone, welcome to ETN'S Classical Academy. So we're going to look at this question which is under proof the identity trigonometry. So if you're in college, if you're in high school doing pure mathematics in whatever country you are in, you have to learn how to prove the identity. So this might come in your test or in the exam. In your first year university, you have to learn also how to prove the identities. If you're doing pure mathematics, you're doing ADMA, college mathematics, you're at any university, please leave a comment on which university you are at or which high school you are at so that I can be able to have a good algorithm. And please like this video and share. Let's get started. Subscribe to my YouTube channel. So let's get started. So prove the identity 2 over cos power 4 theta minus sine power 4 theta plus 1 is equal to sec squared theta. Now we have to understand one thing here. What does what does sec theta mean? So if you can know what sec theta means, the work is almost done. So let me show you what it means. So I'm going to use this side. I'm going to use this side to prove what I'm trying to say. So let's see what we're going to do. Before I begin, let me just explain a few things which you have to understand. Okay, so understand these few things. If you have sec theta means what? So sec theta is the same as 1 over cos theta. It's what sec theta is. So if you see sec theta, same as 1 over cos theta. But if you see cosec theta is the same as 1 over sine theta. Hope my voice is audible enough for you guys to understand. So sec theta is the same as 1 over cos theta. So if you can know this rule, then the job is almost done. But though we're still going, the rule which you won't learn at your school is this rule: sine power 4. Sine power 4 theta is the same as 1 minus cos squared theta squared. That's what it means. This rule you won't learn it at school. But since you are at this channel, make sure, that's what I'm saying, that please subscribe to my YouTube channel for you not to miss on how to become the best in mathematics. Then cos power 4 theta is the same as 1 minus sine squared theta squared. Alright, so remember that sec theta is just 1 over cos theta. So how can I make my work easy? What must I do for me to make my work easy? So the thing I can do is this: I can try by all means to simplify the denominator. Alright, so I've shown you what those represent. Okay, so I can try to change one of them to suit my needs. So I'm trying to prove this side. Remember, I'm proving this side, right? So what I'm doing, so I can try to change any of them. So which one can I change? Can I change sine power 4? Can I change sine power 4? Or I should change cos power 4. So if I want to change something here, okay, let me say I want to change what cos power 4 is. Let's say I want to change what cos power 4 is. I said, how do you express cos power 4? We said cos power 4 is the same as, remember the rule? Cos power 4 theta is the same as 1 minus sine squared theta then squared. So here where there is cos power 4 theta, I can replace 1 minus sine squared theta power 2. So let's see what we're going to have. So we said here we can just replace, okay, let me write a clear stuff here. So we said here we can just replace, open bracket, 1 minus sine squared theta power 2 minus sine, remember, power 4 plus 1. So now I have this now. How do I expand this stuff? How do I expand 1 minus sine squared theta power 2? So you can use either, you can multiply this method like this, or if you want, you can just use what you call the Pascal's triangle for binomial theorem. So since you are here at this channel, we're going to make mathematics easy. So we won't be expanding like the way school wants it to be done, but you still have equal marks. So we're going to use what we call the Pascal's triangle. So we're going to use the Pascal's triangle. So the Pascal's triangle says that when you want to expand a number with a square, you have to use what we call a plus b. Now a plus b, this one represents your a and that is your b. In Pascal's triangle, how you expand a square is by following what we call 1, 2, 1 if it's power 2. If it's power 3, I'll show you in the next video when we do binomial theorem. Alright, so this is what you do. So you're going to say, you are going to expand it. Since it's a square, I'm going to use 1, 2, 1. So I'm going to use 1, 2, 1. Now, in case you're wondering, what does this 1 to 1 represent? So 1 to 1 just means I start with a, I go to plus 2ab, then I start with a squared, then I go to plus 2ab, then I go to plus b squared. Now, are you noticing something here? So the powers of a are decreasing and the powers of b are increasing. That is under Pascal's triangle in binomial theorem. Now, your a is 1 here. Your a is 1. So let's see how we can expand this. A is 1. So I'm going to have 1 squared, then plus 2. Your a is 1. Your b is negative sine squared theta. Alright, then plus your b again, negative sine squared theta, then squared there. So after expanding that, I'm using different boards because of the space. This question is very long. So after solving that, you're going to find that you're going to have 1 plus 2 times 1 times negative sine squared theta. You're going to have, the answer is going to give you negative sine, yes, so we're going to have negative sine sine squared theta like this. Then here, when you do negative sine squared power 2, you're going just to have plus sine power 4 theta. So we have known what this is, right? So let us replace correctly and see what we're going to end up having. So let us see. We have known what this is. So this part can be replaced with everything we've written down here. So we're going to replace with 1 minus sine squared theta plus sine power 4 theta. So if you can notice like terms, you can deal with them. Like terms, you can see that these two are like terms, these two. So what is sine power 4 minus sine power 4? You're going to get a 0. So you're going to get a 0 for this. This will go. I hope you're seeing what we're doing. So you get a 0 for that. Then what we can see is this again. We're seeing that there is 1 plus 1 there, right? We're seeing that there's 1 plus 1 there. Okay. There's 1 plus 1 there. I think we forgot to put a 2 here. So put a 2 here. There was a 2 there. Alright. So we're also seeing 1 plus 1. 1 plus 1 equals to 2. So what we're going to do is these two have gone. I've got 1 plus 1, which is equal to 2. So what we're going to have here is this. We said 1 plus 1 is 2. So we're going to have 2 minus 2 sine squared theta. That's what we have, right? Okay. That's what we have. So can this be factorized? The answer is yes. What number can go in 2 and 2 leaving a remainder? It's a 2, of course. So if I factorize this part, I'm going to have 2 open bracket 1 minus sine squared theta, since I factorized. Now these 2 can cancel out, right? What remains here is I'm going to have 1 over 1 minus sine squared theta. Now remember the rule that 1 minus sine squared theta is the same as 1 over cos squared theta. So what I'm going to have is this. I'm going to have something like this, 1 over cos squared theta. This is the same as sec squared theta. So we have proved. You can even write QED, quite easily done. So this is the most feared question in pure mathematics, but we have known how to solve it. So please make sure you like my video, subscribe to my YouTube channel. If you have watched up to this far, please make sure you like my video. If you want tuitions, my line is +260 978 03 5540. In whatever country you are watching me from, comment the country, comment the university, comment the high school. So thank you so much. This was ETN's Classical Academy. Subscribe to my YouTube channel, guys. See you in the next video.